Okay, what you're looking at is a parabola. Okay, let's just write that out. Parabola. Because we're going to be talking about parabolic mirrors. Well, I wrote parabolic. Parabolic mirrors. That's what we're talking about. And what you're looking at below is a parabola. Now, let me just erase this. I'm going to need the room. Now, we've all seen parabolic mirrors. As a matter of fact, I showed you a parabolic mirror in class. It was in the shape of a flashlight. And I told you in class that that flashlight was designed with that parabolic mirror so that the bulb, now let's put that bulb right here, that bulb in the parabolic mirror would send the light beams after bounce using the laws of reflection. All those beams would go straight out. Okay, let's do those with some lines, make it a little clearer. Okay, if the line came in like this, it would bounce out like that. And if the light came like so, it would bounce out like that. That's what gave the flashlight a straight beam that was useful for finding things. That's what gives your headlights that straight beam going straight out, that parabolic shape. Well, now that we said that's the shape we're going to be dealing with, let's do a little bit more. Let's get rid of those lines and let's see what happens if the light comes in. And we also did this in class. As a matter of fact, I took some of you outside to show you that if I took a little bit of material, I took just the lens of the flashlight itself, and I put that material, let's change the color here. Let's get rid of this line too. If I took some material and I placed it right where the light bulb should have been, and I held it up to the sun, I showed you that light coming in, hitting the mirror, would bounce right on through that material that I was holding. And sure enough, as that light came in from all different directions, it would catch that piece of material on fire, which it did. Right in the center, that material caught on fire. Do you remember? Well, every bit of light, we could say, was focused right in the center. And that meant that we had a name for that point. It was called the focus or focal point. And we're going to use focus for our word. Okay? And it made no difference if the light was coming in as it was from the sun, all those rays of light coming in, or it made no difference if the light was coming from a light bulb and going out in just the opposite direction. As in a flashlight, the light took the same path based upon how it bounced off that mirror. Well, that's what we're going to be talking about. But you know what? It's a little hard to draw these parabolic mirrors freehand. Okay, so what we're going to do is we're going to establish our own little rule. We're going to start using something called, it kind of looks like this. That's going to be our parabola because it's too hard to draw the other one. And once again, I'm going to show you how those light rays come in. First of all, I drew this by making a big arc. It's not quite a parabola, but for our purposes, it works. And let's see. Let me go back. Let me erase this. And we're going to use this to establish our center point. Okay, that's going to be something we call our center. And the circle that you're seeing, or the arc over here, this arc was drawn using the center point. Okay? Let's establish a few more rules. Let's identify what this point is over here. We're going to call this our principal axis. And this principal axis is what we're going to use as our reference point. So we can put our objects right on it. So we know where to establish. We all have the same rules we can abide by, we can listen to, and we can work with something, a reference point. And that reference point will be called our principal axis. Now before I go on, I'm not going to go too much farther with this segment. Before I establish a few more rules. This is also this line over here is also a normal. It's normal to the surface. In other words, from a few slides back, this forms a 90-degree arc all around. Let's keep this picture here, and I want to show you something else. Let's draw a picture. Let's use some symbols here. Let's use some objects. Okay, let's draw a picture of a circle. There is a circle. Not only is it a circle, it is a wheel. And in the center of this wheel, sorry about that. In the center of this wheel is a dot. That's the hub of our wheel. It is no different than this point right here. Okay, the same one that formed the arc. In other words, what you're seeing on top is just this portion from here to here. And our principal axis on top goes just like that. Okay, so this is what we called a little earlier up on top, our principal axis, the picture just above. But now I said, wait a second, I want to show you something with a complete circle. So let's just pause a second and take a look at what we got. We got our mirror up on top. Okay, so this is going to be our mirrored surface up on top. That's going to be our mirror. Okay, is our principal axis. I'm showing you the same thing down below, how I drew this arc up on top. I drew a complete circle, and then I erased most of the circles, so I just had these small parts left. Okay, I'm doing this for a reason, because I want to show you that all these things, which I'm going to call spokes right now, I'm going to call the principal axis, and you won't see this in any books. I'm trying to create a picture in your mind that you can remember, that this is nothing more than a spoke on a wheel. And if I wanted to draw a whole bunch of spokes, they would look like this. Let's draw a whole bunch of spokes. I'm going to draw a spoke from the center. It's going to go like that. Draw another one here. I'm going to go right around this whole thing with a whole bunch of spokes. And every one of these spokes forms a 90-degree surface. Every one of these spokes forms a normal. So this is 90 degrees. This is 90 degrees. This is at 90 degrees. Even though it's a circle, remember I can magnify this a zillion times. I'll do that in a second. All these are 90 degrees. And let's magnify this section right over here. I'm magnifying it. And when I do, it's going to look like this. Let me change the colors a second. That's what I want. I'm going to change that color, and I'm going to magnify this section right over here. Okay? And here it is, magnified a zillion times. Well, gee, it's magnified so much it looks like a straight line. And that normal going through it looks like this. Okay? And you can see that I said that this is 90. And sure enough, magnified a zillion times, this point looks like that. All right, so we established that coming from the center up here, I can make a whole bunch of spokes that go anywhere and hit that mirror down below to the right and form a 90-degree normal. I can draw any one coming straight down, and it's going to form a 90-degree. I want to carry it right on through, just like the picture down below. So let's go back to our basic picture and see how this works out for us. Okay, we said that this arc over here was drawn because I was able to establish a C in the center and draw an arc. And I had a reference point I called my principal axis. And it just so happened this formed a normal, like one spoke on a wheel. So that this was, all these were at 90 degrees, 90, 90, and I'm not going to draw it on the other side. Okay. Do you remember in the last slide we had a focus, a focal point? Well, here is another rule. The focal point is always halfway. I'm just going to label it with an F. Halfway. 1/2 the distance to the mirror. Okay, from here to here, going all the way up, it's 1/2 the distance to the mirror. Okay, so now we know where our focal point is. And we can erase the 90s because we've already said those are 90s. Great, we know that. How do we find an object? How do we find the image, rather, given an object? Let's try doing that. And you're going to see how really easy this is. First of all, let's put our object over here. Okay? And just so we can remember this is our object, I'm going to put a little O above it for object. O for object. Well, it's supposed to be an O. You get the idea. Okay. Let's make it a better O. Or someone calls it, says Mr. C. O for object. We got a few rules. The flatter the mirror, the more accurate these lines are going to be. Now, I'm not going to confuse this drawing by trying to draw a flatter portion. I'm simply going to make approximations that will suffice for you. We just don't have the time to do it as I would if we had extra time to establish those the flatness of the mirror for me to redraw it. So, Let's use it as you see it right here, even though a flatter mirror would be more accurate. But let's go. First thing we've got to do is we've got to draw two rays. Our rules are going to be these. We are going to draw, let's see, two rays must come from a single point. Okay, that's our rule number one. And we're going to have rule number two. And rule number two, that was the first. Let's call this the second. The second rule. Where those rays cross is where, not to where, is where our image will be. Okay, we got two rules. And don't forget the original rule from before. I'm going to add that as well. Let's call it the big rule. The big rule. Angle in equals angle out, and we're talking about light rays, when measured to the NORMA what? MAL. Okay, that's our rule, our big rule. Well, angle in equals angle out when measured to the normal. Let's draw a light ray coming in. All right, I'm going to draw this light ray coming straight in parallel to the principal axis. Now, I'm doing this for a reason. Do you remember earlier? Do you remember earlier when I said that with a reflector on a flashlight, I took it outside. I'm not done because I want to show you something else. I'm going to take this center point right there, okay? And I want to show you that if I draw this as a straight line, let's see if I can do that. Control. I'm going to draw this as a straight line coming from here. Oops, I don't want to do that color. I want to do, let's see. I'm going to try and draw this as a straight line going right up through that point right there. Okay? I drew that as a straight line coming straight back. That is one of our spokes from before. Can you see that this is a normal? It is the same as the normal down here on our principal axis. It's coming from the same point, and if it helps you to remember that it's nothing more than, it looks just like a spoke on a bike, that's fine. But can you also see that coming from this point, this angle right here, angle I is going to equal angle O? Because it does. So even if you forgot this picture down here, that light rays coming in parallel bounce through the focal point, drawing the smoke from the center does the same thing. Now, I'm not done yet. If light, remember our rule number 1 up here, this guy right here, 2 rays must come from a single point if you want to find the image. Well, I'm going to establish another ray of light. I'm going to bring down another ray. Okay, let's try and make this one, I'm going to try and make it a different color. I'm going to try and make this one green. I don't know if this is going to work. Okay, well, don't know that it will. Well, I'll tell you what. We'll make it the same as the last one. Oh, yeah, there it goes. Let me undo that. 1 second, please, as I try to get my tools working. I may have to show it just like this. I'm going to take another ray of light, and I'm going to bounce it through the focal point. Okay, right like this. Now, if that second ray of light goes through the focal point, do you remember my image with the flashlight? That light coming from the focal point goes out in parallel? Because this guy is going to go out in parallel. And I'm going to highlight this so you can understand what I'm saying. We have to take 2 rays of light. I took 1 ray of light, it came in like this, hit the mirror, and bounced out through the focal point, like so. It came in parallel with the principal axis, and it bounced through the focal point. If I had forgotten that, I did not need to worry, be concerned, because I could have also realized the same thing by using this normal, that the angle in was going to equal the angle out when measured to the normal. Now, I had to take a second ray, and I took the second ray from the same point. I don't know if it's going to work or not. The second ray came down like this. Let's try and make this, let's see if we can do a little better job on this. The second ray of light came down through the center, like so. I'm trying to color it, like so, and bounced out. As it passed through the focal point, it bounced out this way. Now, both of these rays of light meet at this point right here. They meet right at that point right there. Look at the second rule. Where those rays cross is where our image is going to be. There's our image. Our image is inverted. Okay, our image is smaller. And these light rays are coming together. This one and this one came together and crossed. Because they crossed, we call them And if light rays converge, then you have a real image that can be projected onto a screen. That can be projected.